Hello and welcome to today's video. We're going to talk about subsets. So this is a really important part of set theory. It's a really important part of discrete math in general. So make sure you pay attention to this one. So we call B a subset of A if every element in B is also in A. And a good way to think about this is kind of visually. So B is a subset of A if every element in B is in A. So that means that A has to be bigger, right? Because every element of B is in A. So that means this must be B. So let's call that one inside must be B, and the larger one must be A because every element in B is also in A. So that would be B is a subset of A, and the symbol is this right here. So B is a subset of A. But what I want you to also notice is what if they were the same size? So if B was here and then A was here, so same circle, so B equals A in this case, they're the same set. Would we also call it a subset? Well, based on this definition, B is a subset of A if every element in B is also in A. Well, that's still true. So B is still a subset of A. So that's an important part to know, is that they can be equal. But then you get into something called the proper subset. And this second example would not be a proper subset. So a proper subset kind of takes away the equals, and you would write B just as a subset of A. And this is called the proper subset, and so it does not equal to. So that means this B is not a proper subset of A, so that's not true. But for this first one, B is a proper subset of A. That's kind of a technical thing. You might see that show up. I'm not really sure, but that's just something that you might want to know. So that's proper subset. Okay, so the empty set, another important part is if B is not a subset, we put the dash through. That's what I just did with this proper subset, so hopefully that makes sense. And the third thing I want to talk about is the empty set is a subset of any and all sets. This is a really important thing to know. So empty set is a subset of everything. And the way I want you to think about it is, remember that the empty set, so that's this symbol, is just this. It's just the set containing nothing. Well, the idea is that any set, so if I have set A equals 1, 2, 3, for example, the idea is that there's some space in between, like the empty set might be here, it might be here. There's going to be somewhere where there's nothing inside of the set. So that's why the empty set is a subset of A and any other set. It's always a subset. So hopefully that makes sense as well. All right, so let's get into this example. Let me erase this proper subset. I'll just leave it there so you guys can write it down if you want. So now the example here. A is 1, 2, 3, 4, 5, and B is 2, 4. So first question is A a subset of B, or is B a subset of A? Let's think about it here. So we actually can do the circle here. It actually might make it a little easier. So let's name this one A, and let's write our element. So we have, well, I'll just write it a little differently. So let's put B inside. B we know is 2, 4, and the thing is we also see that they are in A, right? Because 2 and 4, and then so in A we have 1, 3, and 5 still inside of A, but not in B. So this shows you kind of clearly, this one being B, that B is going to be a subset of A. So B is a subset of A, and B is also a proper subset of A. You don't have to write that down, I just wanted to show you there. So B is a subset of A, and now another question is A a subset of B? Well, are any and all elements of A inside of B? No, because 1, 3, and 5 are not in B, so that is not a subset. And okay, and then the empty set is a subset of A, and the empty set is a subset of B. So a good thing just to write down anyway. So hopefully that makes sense. Hopefully now you kind of understand the intuition behind subsets, and now let's get into some more practice questions. All right, so the first one, we've got 1, 5, -1, 5, and 10, and then we have set -3, -1, 5, 7, 8, 10. So let's name this one A, and let this one be B. So clearly you're going to notice something about the cardinality. So this is kind of a rule I probably should have put on the first slide, but cardinality of A related to the cardinality of B. There's something about this that can make subsets impossible. So if cardinality of A, let's make A greater than B, then what do you think happens? Well, let's do it less than, just because that's what this example is. So cardinality of A you see is 3, and cardinality of B is 7. 1, 2, 3, 4, 5, 6. So B is greater than A. Well, that means that B cannot be a subset of A. Then B cannot be a subset of A. And if you think about this, it makes sense because cardinality is number of elements. So remember that hopefully from some previous videos. If the number of elements in B is greater than the number of elements in A, then all of the elements in B can't be in A. So that's kind of the quickest way that you can check this, is you can just say, okay, B has more elements than A, so B is not a subset of A. So that's what I would write first. So B is not a subset of A. I know that right away. And that's because of the cardinality, because cardinality of B, let's just write this down here. Cardinality of B is what? 1, 2, 3, 4, 5, 6. Cardinality of A is 3. So clearly B is not a subset of A. Now the question is A a subset of B? So B is not a subset of A. I meant to write that thing right there. Okay, so the question is A a subset of B? I said, and this one is not as easy. You can't just say, well, the cardinality of A is less than B, so it must be a subset. That's not how it works, because remember, all the elements have to be included. So what we want to do is we want to kind of map it. So is -1 inside of B? Yes, it is. Is 5 inside of B? Yes, it is. And is 10 inside of B? Yes, it is. So all the elements in B in A are inside of B. So A is a subset of B. And A would also be a proper subset of B, because they are not equivalent. So that's how you do that. And this rule is important. So cardinality, it's just the easiest way to check the subset rule. So if you know the cardinality of the two sets, you can easily check if one's a subset of, if one is not a subset of the other. All right, so example 2, we have the empty set, and we have set -3, 5, 7, 8, 10. Okay, so let's name this A. Let's name this B. And remember, the empty set, we talked about this earlier, is just the set with nothing inside of it. And remember our rule, we said the empty set is a subset of everything. So we automatically know that A is going to be a subset of B, because the empty set is always a subset. And it's hard to kind of explain it, but like I said last time, you kind of assume there's always this empty space. There's nothing inside of here, so you assume there's somewhere inside of B, with just some empty space, and that's where the empty set would be. So empty set is always a subset. Important rule there. I just wanted to make sure that you guys all got that one. All right, so now the next one, we have -1, 5, and 10. Let's name that subset A. And the natural numbers we'll just leave as N, because that's already a letter form. So yeah, the key here is recognizing that that N means natural numbers. So this symbol is for natural numbers. Hopefully you know that the Z is the integers, Q is rationals, so on and so forth. And remember, the natural numbers are often called counting numbers. They're the set, so N is the set of 1, 2, 3, 4, so on and so forth. So it's all positive integers is another way to do it. So equals Z plus. So positive integers. So now is N, notice the cardinality of N is technically infinity. It's infinite. There's not a finite number of positive integers. It goes on forever. So cardinality of N is obviously way more than A. So that means that N is not going to be a subset of A, because N is a lot bigger. You can't have something with 1,000 elements a subset of something with 3 elements. But now, is A a subset of N? And no, it's not. It's pretty obvious here, because we got this -1. So -1 is not a natural number. So that means that A is not a subset of N. And that's our answer to this question. So that's all I have for this video. Hopefully that makes sense. Knowing and understanding the subsets and maybe the difference between proper subsets is pretty important, and you're going to have it come up a lot. So definitely know the empty set is a subset of any and all sets, very commonly tested topic, and also know the rule about cardinality that I wrote down here. So if the cardinality of A is less than B, then B cannot be a subset of A. Just an important rule to note, and it should be pretty intuitive. Alright, so don't hesitate to contact me with any questions, and thanks for watching.